head off away from the center of the icon based on where they are in 3D space. So if I scrub the timeline, there you go, they're all flying off basically in a spherical manner. That's because obviously we're using a spherical icon. If I change it to a circle, we actually squash that down into a horizontal plane. If I change it to a rectangle, you can see we're getting the same kind of thing, but it's based on a rectangle now. And if I change it to a box, we're basically getting the same thing again, but it's heading outwards from the box. The particles are being distributed along the edges of the icon. Just put that back to a sphere. So icon center out, that's pretty useful, you know, for producing explosions and things like that. You have this 3D distribution of direction. You know, the other values work in exactly the same way. You can reverse the direction and the particles will actually explode inwards. So let's go on to the next option. Icon arrow out does a very similar thing. It traces the position of each particle back to the center of the icon. But in this case it doesn't do it in all 3 dimensions, it just does it on a horizontal plane. So if you can imagine there's an axis running from the top of the icon to the bottom of the icon, the particles actually trace themselves to that axis, and then they'll just base their direction of travel outwards in a horizontal manner. So if I scrub outwards, you can see that the particles have been shot off, but only in a horizontal direction. But apart from that, you can see it's 3-dimensional, but constrained to the horizontal axis. So that would be more useful if you're producing a kind of ring wave explosion and you don't want, you know, the full particles flying out in all directions. You just want them constrained to a horizontal position. So you can actually use that particular option there. The next option is a completely random 3D direction. So you don't really have that much control over this. Each particle just basically flies off in any direction, you know, at random. So you can see here they're just flying off completely chaotically. You know, you can change the seed to vary that. And we have random horizontal, which again is a random direction. It'll head off in any direction, but this time again it's constrained to a horizontal plane. So you can see all our particles actually heading off in a horizontal plane. But apart from that, it's actually completely random. So you can think of random 3D and random horizontal as being variations on icon center out and icon arrow out. So they're pretty useful as well. Now the last option is inherit previous, and if we scrub the timeline for this particular option, you can see we're actually getting nothing. So what inherit previous does is, as you can probably tell by the name, it'll take an existing speed and well, it doesn't so much take a speed. What it takes is the direction of travel. So it'll take a direction of travel and then it will apply it to your particle using whatever speed values you have here, and that's when they enter the event. So if you have an animated speed value here, the value will actually apply to the particle as it enters the event. And you can see with this particular operator there's no animation offset, so it's absolute. When the particle enters the event, if the speed value is 10, that particle will get that speed of 10, but it will actually keep its original orientation and carry on traveling in that particular direction. So what we'll do here is we'll assign an icon center out speed, which we now have our speed, and I'll turn on this test here. And this test is set up to do a random test on age, and it'll test for particles which are anywhere between 1 frame old and 19 frames old. And then if we have a look here at inherit previous, which is actually in another event, we've got a speed operator with that option. You can see that I've actually animated the speed value, and it runs from 1 all the way up to well, from frame 20 it starts animating, and then all the way up to frame 40 it goes up to a speed of 50. So if I turn on the age test here, the particles will be passed anywhere from frame when they're 1 frame old to 40 frames old. They'll get passed to this event, and then from frame 20 onwards the actual speed value assigned to them will actually increase all the way up to 50. So if we scrub the timeline, some of the particles are actually, if I deselect this, you can actually see it with the color. So you can see some of the particles are actually heading into the second event straight away. They're becoming blue, and they're being assigned a speed value of 1. This carries on, and you can still see we've got some red particles, so they haven't actually been tested true yet and passed on to the next event, so they're still red and they're still traveling along at the initially assigned speed. But now if we carry on scrubbing, you'll see that some of these particles actually speed up and start flying off. So these are particles which are actually entering the event right at the end of the animated range, and they're being assigned a speed of 50. So if we zoom out a little bit, and I'll just get rid of the grid, I'll press play, and you can see these faster particles are flying off into space. If I go back to here and I assign a very slow speed value, there we go, and press play, you can probably see it a little bit more clearly now, because in the first event the particles are being assigned a I'll actually get rid of the variation as well. The particles are being assigned a speed of 5, so they're all traveling along at 5, and then they get assigned a ramping value. So inherit previous is very useful. You know, if you want to have particles come into an event and then you want to slow them down, but you want them to keep their original orientation, you can inherit previous. That will keep their orientation, and then you can modify their speed using the speed and variation values. Or, you know, obviously you could reverse them, or you can actually have a little bit of divergence on their actual direction of travel. Let's try that. We'll move it outwards, and we'll do it here, and we'll put some divergence. There we go. So as the particles are assigned their new speed, they're now actually diverted away from the original orientation as well, and that's based on the divergence value. So you can see as they come in, some of the particles take off in a much more sort of random direction. There's a little bit of an offset going on their direction of travel. So there we go. Quite a cool operator. It'll be used a lot. It's, you know, it's very standard, and you know, you can see the options are pretty easy to understand. Inherit previous is probably the odd one out in that it actually, you know, it doesn't define a direction of travel, it just inherits a direction. But you know, you can see what it's used for. It's used for inheriting a direction and then working with it. So these are pretty cool. What we're going to do now is we're going to move on to the next operator, which is speed by surface. This particular operator is a counterpart in many ways to position by surface, by object I should say. In that position by object will actually get the particles and position them on an object, and this particular operator will actually get the position on the surface and use that as a definition of speed. It will use the orientation of the faces and the direction from the particle to the face, and use that as a way of defining the speed of the particle. And also this particular operator also allows you to define the speed of a particle based on a texture and so forth. So it's a very cool operator, and it's used a great deal when you want to produce more advanced effects. So let's have a look at that now.